Hi class, I wanted to share a couple things with you before class tomorrow. One thing I've been referring to is your textbook. Remember your textbook? A lot of people aren't using it. But there's an excellent appendix at the end of your textbook. It's Appendix 1. It's right after page 1374, which is the last page of the book. The first page describes the order of priority for different functional groups. You'll see that alcohols are fairly low in the overall priority list, but they are higher than alkenes and alkynes. Now this is how Loudon describes the way you make decisions. And I recommend that everybody read this, and when you feel like you're in a state of utter confusion, look at this. Okay, first of all he says, this is how you pick the chain, the principal chain. 1, the maximum number of substituents corresponding to the principal group, okay? In ours, the highest principal group we have right now are alcohols. So, if you had a big complicated structure and it had lots of double bonds and it had 2 OHs, you would pick the chain that had those 2 OHs in it, those 2 alcohols. So it doesn't mean maximum number of substituents, it means maximum number of substituents corresponding to the principal group, which is the high priority group. Number 2, the second thing you use to make decisions, the maximum number of double and triple bonds considered together. And again, notice that, it's considered together. 3rd, maximum length. I keep saying this to people who are coming into my office. The length is the 3rd thing you use to decide. So if you have more than one chain and it's got the same number of alcohols and the same number of double and triple bonds taken together, you would go with the chain that was longer of the 2, just longer number of carbons, more carbons total. Then finally, number 4, if you still can't decide, it's the maximum number of substituents cited as prefixes, okay? So you go with the chain, finally, would be with just gross total number of substituents. He also gives 4 rules for numbering on the next page. It's page A2 of the appendix. He says, 1, the lowest number for the principal group cited as a suffix. That is the group on which the name is based. Okay, so if it was an alcohol, it would be the OL or the diol. You try to get the lowest numbers for that. Second thing you look into, the lowest numbers for multiple bonds, with double bonds having priority over triple bonds in case of ambiguity. 3, lowest numbers for other substituents, taking into account first point of difference rule. Okay, and then 4th, the lowest number for the substituent named as a prefix that is cited first in the name. And that refers to alphabetizing. A lot of people keep using this word complexity over and over and over again, and I'm not sure what you're talking about. Okay, so the only way complexity comes into this is that if you have 2 chains that are the same length and one has more substituents than the other, you pick the one with more substituents. I don't really know how you would evaluate complexity. It seems like kind of a little on the quality, a little bit on the subjective end of things, the way you guys are using it. Okay, so I don't know where that came from, but I would kind of like wipe that out of your vocabulary and accept the fact that I'm not going to give you really ambiguous problems. I'm really not. Okay, that's not the point behind this. The point behind this is to teach you the language and to teach you a hierarchical way of thinking, which is very useful in the course. It is not to give you the wildest, most ambiguous situation that is impossible to figure out with the basic substitutive rules. And you're always going to come up with something wild that we can't do with these rules, or that we would have to look up to figure out. Okay? Now, there's a couple other things I wanted to say, and I keep saying this to individuals who come into my office. The first thing is, when do you leave the number out in the backbone? Okay? Is there some kind of problem? Okay. So first of all, the only time you do not use that number 1 is really when you have one high priority group in a ring. That's the only time. So, for example, in a molecule like this, if I have an OH and a double bond, okay? This is the principal group. So the name is based on that. This would be a cyclooctanol. You would not need the number for that alcohol. So I could call this cyclohexene, all, okay? But I put a number for this double bond, so I'd go 1, 2, 2 cyclohexene all, okay? So notice I don't need the number there. However, when you have chains like this, and let's say I have an OH here and an OH here, okay? And let's say I have a double bond here and another double bond out here. What I would pick as my principal chain would be this, simply because it has 2 of the principal groups in it. Now, my next concern would be to get double bonds in it, but the way this is set up, I can only get 1 double bond in it, and one of them is necessarily excluded. In terms of numbering, we do not call that number 1. All right? The end of the chain is number 1, so I would number this way so that that alcohol got the lowest number. That's what the rules say. This is like probably the kind of level problem you should be able to do by tomorrow. Okay, these 2 are at the right level. This one's a little bit harder, but I just want to show you something. This would be called an undecene. Now watch this. Leave the E, diol. You almost never, I can't even think of a case where you leave the numbers out with these functional groups in a chain. You have to put the numbers in. If there was 1 alcohol, you'd put the numbers in. But what I'm pointing out here is a lot of people start calling that number 1 because of the ring situation. So this compound is an undecene 2,6-diol, okay? And the double bond is in the 1, 2, 3, 4, 5, 6, the 6th position. And again, I'm using kind of I'm going to call it now the traditional nomenclature instead of dating it. All right, the only substituent hanging off of this is this group, and this is a 5-ethenol. Now, ethenol. Don't forget that YL ending. It's a side chain. Now, this is one of the other cases you don't put a number in. All right. So let me sum these up. Okay. So what I said was that the only time you do not put the 1 in is in a ring for the principal group when you only have 1 of them. If I had 2 of them, I would have to number these 1. I would go 1, 3 in that direction. Okay. All right. Supposing I have something like this. This would be the other case for you guys. If you had a double bond in a ring, let's say in a chlorine like that, that would be the number 1 position. So you could simply call this 3-chloro. Take that back. It's 4-chloro. Because you have to encompass the double bond in the numbering. So this is 4-chloro cyclopentene. I don't need the number here. It's implied because that has to be the number 1 place. So this really only applies to rings with 1 for the highest priority group, and if you only have 1 of them. If I put another double bond in, I have to number both double bonds. Okay, now, where else do you not need to put numbers in? Certain complex side chains. Which ones? The methyl-ethyl. There are more, but I'm just going to write the ones that you run into most frequently. The dimethyl-ethyl, the ethenol, the ethynyl, and really any group that's built on a methyl group. So, for example, a bromo, methyl, anything like that. We did these little cyclopropyl methyls. There are others, okay? There's no doubt that there are others. But these are really the simple ones you run into all the time. And I don't think you should be losing sleep on this number thing. And then the other suggestion I made in my second class the other day was that you can leave the parenthesis out if there's no number corresponding to the complex side chain, but you're not going to get in trouble for putting the number in. The parentheses is used to kind of segregate the group and segregate that number from the number for the position on the chain. Finally, there's one other thing I wanted to say. Now I'm forgetting what I was going to say. But anyway, in class the other day, I just said in the second class we were 10 minutes behind schedule, and I heard people were very upset about that. It's not a big deal. It's just that you're a bigger class, and in a bigger class there are more questions. In a bigger class, problems move slower. That's all. And I just try to keep you in line, because in class, it is really important that we cover the material for the course. It's really important. I know you know that, but the thing is, if we get 10 minutes behind every day, I can't cover the material for the course. And I don't think that's such a good thing, because we're trying to do an organic chemistry course. So just kind of keep that in mind sometimes. But one person did ask a really good question, and she said, you know, like, could you do a problem, and I was kind of out of time, but she said, could you do a problem where we have to draw a structure from a name? So supposing you had something like this, supposing your root name was, I don't know, we're going to do something kind of wild here. Let's say it's in a dough. Let's make it really big. I hope my thing works here. You can criticize it if it's wrong. Dodeca diene ein all. Okay, so let's make it pretty big. So let's make it a 2 all and like maybe a, let's see if this works, a 4 ein. We'll see if my name's good. And then like a, I don't know, a 6, 7. Let's see if this works. Maybe I'll put it a little farther out. I'm guessing a little bit here about the structure. I'm trying to visualize it. So 7, 6, dodecadiene, 4 ein, 2 all. And then really I can put any substituents I want. So let's say I say let's see, I got to stay away from that triple bond. So let's say an 8 bromo methyl 9 2 chloro, I ran out of room here, propenyl 2 propenyl. Okay, so let me try this. I don't know. Let's see how it's going to work. So what I want to draw is 8 bromo methyl. We can criticize and say, did she write a rational name for this thing? Because what's interesting to do is to go back the other way and see if you get the right name again. If your name made sense, because I might have broken some rules here when I did this. Let's see how this comes out. I tried to space things out. 7, 6, dodec, diene, 4 ein, 2 all. All right, let's see if this works. So how do you do this? All right. So how do you do this? What you do is you start with this. Okay. So I start with that. Really, I want to put 12 carbons. So I'm going to put 12 carbons. I'm just going to zigzag them along so we can do this pretty quickly here. Okay, 12. All right. Now it says it's a 7, 6 dodecadiene. So if this is 1, 2, 3, 4, 5, 6, 7, it says in this position. That's kind of weird. I guess I should have said 6, 7 here, so I'll criticize that right now. But in this position, wow, they were like piled right up on top of each other. So let's see if this works out. You can do that, so it's not crazy. So it would be that 6, 7, dodecadiene, 4 ein, 1, 2, 3, 4. Boy, things are tight, but it'll work. Now that has a different geometry as we're going to learn in class. These are called cumulated double bonds, and they do exist. 2 all, so there'd be an OH right there. So you see I put in the 6 and 7 position 2 double bonds. Let's check that. 1, 2, 3, 4, 5, 6, 7. Triple bond in the 4 and OH in the 2. All right, then it says in the 8th position, I have a bromomethyl, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I just made it there. I'm going to put a bromo methyl. That means a bromine on a methyl group. And a 9, in the 9 position, a 2-chloro-propenyl, 2-propenyl. So I have to draw a propenyl. That's 3 carbons, and this 2 refers to the double bond position. So the double bond has to be there, and then it says in the 2 position there's a chloro. Now this looks okay to me, but do you know what? When I look at it now, it's not. This is really cool because this is not a good name. Okay? Why is it not a good name? Let's criticize this. I like this. Let's criticize it. Okay? I'm allowed to make pretty long movies. Okay. So let's criticize it. Well, and this is what you can do when you practice. You say, wait a minute. You put a double bond off on that side chain. So what happened? What happened, if you follow those rules I gave you at the very beginning, you pick the longest chain containing the principal group. That's the OH. Now that would either be this chain or this chain. All right. Second thing, total double bonds and triple bonds. So this is really part of the main chain in this molecule. So if this were named properly, this is kind of like a classic problem. If you go to the end of and go in Latin, he always gives you like the wrong name, and he tells you to figure out what the right name is. So we're figuring out the right name here. So this is actually the main chain. So how would our name change if that's our principal chain? Well, the chain is the same length. It's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is going to become, it's going to change a little bit. Let's erase all this up here. This is going to be a dough. Let's give myself lots of room. A dough deck triene, because there's 3 double bonds. Do you see why I did that? Because I can get that in the main chain. Triene ine all. Okay? And really, it becomes much simpler when you do that, because where are the double bonds? They're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a 6, 7, 11. Dodecatriene, 1, 2, 3, 4. 4-ine, still 2-all. Okay, so when I was envisioning it and I put the double bond on the side chain, I didn't picture it as being the main chain, but it was part of the main chain according to the rules. Now the side chains become very simple now, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 7. So it's 7 bromo, 7, 8, 9, 10, 10 chloro, and then 8 propyl. All right, that goes in there. 6, 7, 11 dodecatriene 4-ine 2-all. So what I did there was I tried to conceive a name out of the air. I wrote the structure for that. Now it's exactly the same structure as I have here, but then when I looked at it, I realized that the side chain I had created in my head should actually have been part of the main chain. And that's a good exercise too, is to correct incorrect names. Okay, so that kind of covers that issue. The other thing I was going to say is, just because of a lot of issues that are going on, I was going to make you something. I told you I was going to make you a hybrid treat for tomorrow, but I'm going to do it on Monday when I have time over the weekend, because I just can't do it tonight. So don't think I forgot you tomorrow when we go into class. Okay, so I'll see you tomorrow.